I'll quickly go over the creative assignment first. So generally, good job, everyone. 1 second. Okay, can you hear me okay? Okay. Okay, cool. As you maybe have noticed, your creative output is now on the GitHub front page. So if you have a look, this is a little poster for safekeeping. And below there's 2 links. So one is a results image, which will have your score. I tried to be fairly lenient with this. This was supposed to be a fun assignment, which kind of teaches you something along the way. There's also a high resolution version of the poster. So well, I hope nobody feels wronged by the score. I can see that most of you have taken some time to experiment and come up with something interesting. 1 second. Oh yeah, if you go on the Git repository and just scroll down in the README MD. So if you look at my screen, yeah, you can see it here, and the results. Well, let me just click. If you just hit download here, you should be able to see. So, assuming well, I assume everybody remembers what they did. So. So that's that. There was a couple of, well, it was a creative artistic assignment, and there was some really nice images out of it. However, I did also ask for some specific things because one of the reasons for doing this was to have another perspective on code factorization and using functions and being more comfortable with program flow and using conditionals. So I did want to have a use of math function, a use of a function that you've created, a logical operator, and most of you have provided these. In some cases, I was giving partial credit for extra effort because, well, some of these images certainly took a lot of time to get right. So if you had the technical side taken care of, then you definitely didn't need to worry about your score. Aesthetics, this is very subjective thing to grade. Well, I tried to be very open-minded. Some of these were really quite amazing, I have to say. Let me have a look at maybe some examples where, well, I'm not gonna be naming names. Let me just do it in a anonymous way, but there's maybe some samples that I can show that illustrate well what I've been looking for. So let's see. Okay, let's have a look at this one. So this was an example where definitely there was lots of credits for making an effort and putting in the hours. However, you can kind of see that this is like one long string of continuous instructions, and I can assure you that if you came back to this code, maybe in a couple of weeks' time and tried to correct something, then it would be very difficult for you to find which part actually did something. So this would have been a good place to actually use a function and for purpose of self-documentation, for example. Well, just as an example, let's see. Let me stop execution here, and let's assume that maybe this part let's say maybe this part does the hair, so let us just plop it in. Another thing here is you can call that function, so let's say this is hair. I'm just guessing, I'm not going to test this right now, but you know, and a lot of you have done this, so using functions as a kind of a refactoring means in this case does sometimes help you just you know, keep your code organized, and in this case you know, there's definitely a lot of very manual kind of like manually originated work, and you know, it's quite impressive, and the end result is also quite nice. Well, in future, like, always think about, okay, have a big long stretch of code, will I kind of know my way around it? So one way obviously is to use comments heavily. Another is to like break it into logical chunks, and you know, methods and functions are quite a nice way to do it. Let me move on to another example. I won't spend too much time on this, but I think it's kind of worth closing this chapter anyway. So okay, so this is quite a nice little simple design. So you know, all of the examples I'm showing, I think everything, they all had above 75% score anyway, so there's no fear. But let's have a look at what we could possibly make do better in a situation like this. So here, what was missing is okay, the author didn't create a external function that was called. So let's see what you know. And I understand. Okay, if you create an artistic design, you know, maybe thinking about the you know, code layout isn't the most important thing and foremost in your mind, but after we have finished, it's kind of nice to clean up and refactor. We'll be coming back to it as well, and I think this Blockly example is a nice way to, you know, have a kind of like quick overview of you know, what it actually gets you. So in this case, let's have a look at those code sections. So they look quite similar here. Like, we have a couple of loops, and inside those loops, like, let's say let's look at this sequence of instructions. So these are pretty much identical. Actually, the only thing that differs here is that at the end you turn right, or here in the end you turn left. So what can we do? Again, using a function that would have given you 20% of the score for this exercise anyway, just doing this. So let's call it circular. Let's call this function circular, and here in the options, additional options, I'd like to have an input. So I'd like to use an input, and I'll call the input left, or is left, whatever. So I'd like to move all this code in here. Okay, and then I'm going to call this function here. Only now I need to provide this argument. So let's make it okay. The first one was actually turning right. So I created a parameter which is of Boolean type, and I call this function now with this Boolean parameter. In this case, I'll be calling it with let's say let's take it out of here. So this is what I'm trying to get here, is that I don't have to have this repeating code all the time. I encase it here in this function called circular, and I just call it with a different parameter. So, you know, this we can actually totally throw out at the moment. But we'll have a closer look at this final command here. So we'd like this to be conditional. So again, like, there was a request to use you know, logical operators. So Yeah, let's do that. So let's put an if function in there. Sorry, if statement, and let's use our parameter is left. It's variable, yes. And do something if this is left. So if we set this to true, then we turn left by 1 degree. What happens if it's not true? What happens if we want to call it with false? Well, then we have to just add another case here. So else statement and turn right. Okay, and this is basically identical to functionally to what the artist had in the first place. Any questions about this? Possibly, I don't know. Can you see it clearly? Well, okay. This should be fairly clear by now. Anyway, hopefully. Let's jump to like a very nice example of parametrization. So aside from being able to have a code which is clearly organized and code which doesn't have too much repetition, it also helps you with your creativity and reuse of your code later on. So maybe you've created a an interesting function here, and this was definitely I think scored very high there on all the technical requirements, and also looks pretty interesting. So this was really nice effort. Let me see what's happening there. Not sure if you can see very clearly, but this is the kind of spirograph type flowers, and this flower generator has a couple of parameters exposed. So assuming I want to maybe create more of these with different parameters, it makes it very easy to do some kind of like a larger design with this. So so yeah, use functions, use inputs, make your code parametric, avoid repetition. So keep these things in mind. Like I said, I suggested to some of you to if you do have a spare moment, go through these exercises. They do teach you actual programming concepts in kind of a fun way without looking at too much and working with too much code and text. But we won't be coming back to this. But these concepts we talked about, and also the creative approach to development. Also, I'd like to kind of like ask you to see if you can transplant it into the world of C# and Unity, because we'll be having another assignment where I will ask you to do something that you have to do anyway for your final project, which is basically set up the layout of your own city and use create maybe different functions from what I've given you. So I'll talk about it next week. For today, well, if everybody's happy, I'll move on from this. Or is there any more questions? I think yeah, okay. So today, to get started, I'd like to ask you to clone the master branch from the main course project. So this will give you a starting scene in Unity, like perhaps some of you already have done it. You should open a scene called 9 nav meshes. So this will be our starting point. This scene at the moment doesn't do much, but I have provided quite a lot of code. We won't be doing a lot of live coding, a little bit, but I did add quite a lot of new code that would be worthwhile to have a look at after the lecture. I'll go over some of the changes. So I've is everybody up to speed with the Unity projects? Do you have it open? Do you still need a few minutes? Okay. You should have the master branch selected by default, so you can clone this and unzip it. If you need a few minutes, I'll just go over the plan for today's lecture. Are you able to find it? You should see my last commit there from 9 hours ago, AI navigation starting scene. So we'll give you a chance to catch up, and in the meantime, let me just kind of briefly show what we'll be talking about. So AI navigation. So in most scenarios, we need to do some non-player character pathfinding or obstacle avoidance, and I've been told you already should be familiar with nav meshes. So I won't be spending like too much time on the basic nav mesh case. However, there's a pretty interesting distinction there when you are doing your levels procedurally, like in our case. So what you see here is actually some of the code that I will give to you for free to do whatever you like with. Well, with the obvious intention of maybe seeing something like this in the final project. I'm not saying you have to use it, but if you need roads in your city, then perhaps you can also use recursion, your favorite, I know. If you are very confident with the code from the last lab test, if you have a good understanding of what's happening there, then the code that generates these roads randomly is really not much more difficult. It is based on similar concepts, and I'll go over what's happening there as well. But the important part is that it's generated after we leave after we enter play mode. So this recursive code will create those roads, and at this stage we would like to bake the nav mesh for them. Am I right to assume that nav meshes are familiar to you? Have you used them before? Navigation, Unity? Yeah, great. Okay, cool. Well, let's actually do a quick example of a static setup, which we'll bake in the editor. Sorry, was that Kian? You were having trouble finding it, or? Yeah. Or just. Okay, you're grabbing it straight from the website, or? Okay, well, have a look at my screen there. Yeah, it's not the Wix6 initial, it's the master, the default. This should, yeah. So you had a different branch selected. Yeah. Yeah, so once you switch to master, what you should see is exactly what I have here on my screen. So my last commit from 9 hours ago, so you can just download that. Nothing different from the other times. Okay. Yeah, anyway, no worries. Have you used the nav meshes before? I believe Keith might have been already talking about these. Well, let's have a little quick refresher in this case. So open the scene. And let's drop a couple of blocks in there. Like let's use, let's say we use the slope block. So let's drop a couple of these in here. I'll just use Control D to duplicate. You don't have to do exactly the same setup as I'm doing, but and let's use tile as well. So let's create a couple of those as well. I've dropped them at the origin, so I'll be repositioning them in a second, but I just wanted to kind of make sure I have enough blocks to get something started there. Okay, so let's grab the slope, and I'm holding Control so I can just snap it. Yeah, I'll move this tile up a bit. Just create a kind of like some kind of a staircase-like design. This tile block I'd like to maybe rotate. So again, by holding Control, I have snap there, so I can I'll undo it. I can snap to increments of angle. I think I need another tile. Control D. So it's a kind of a painstaking process. It's you know, a level design, as I'm sure you will already have some experience with. So okay, so I have some kind of a very retro looking. Maybe let's put it under a common node to make it easier for ourselves. So I'll just drag it in there. I'll make a quick rough prefab maybe. Let's call this stairs. Okay, and I'm gonna add it in a different configuration now. Okay, that doesn't work so well. Well, something like that. Some loose tiles there. Let's go into this prefab and delete that. Yeah, we don't want that. Okay. Okay, so to work with nav meshes, we need those objects to be specified as navigation static. So yes. Okay, so I'm gonna actually go into the prefab and just make this whole prefab navigation static, and yes, change children also. So I'm doing it slightly different way that okay, we'll see if I don't run into some trouble, but hopefully not. So we have all these objects navigation static. Now this plane, let's say this is also part of our nav mesh. Let's make it navigation static as well. That's correct. Okay. Just a quick check there because okay, let's see. Okay, so this this mesh doesn't have a, well, this object doesn't have a collider associated with it. So that's another important point we're dealing with here. Window AI navigation is where we go to for our nav mesh baking. Where we select our humanoid agent parameters that we'd like to go with. Well, okay. I've set up max slope to be 60 degrees. Okay, let's see. Okay, so thankfully it worked right off the bat. So, well, yeah, since you apparently worked with this, maybe let's not dwell too long, but the important part is here to make sure that the radius of the agent is appropriate for the width of our walkable tiles. Obviously, if the agent is too large, then we'll actually have trouble finding useful routes to this. It just won't fit. So there's a couple of things we might need to play with when we design our level. Okay, so once we have the nav mesh baked, and here you can see it as this blue overlay. So again, I'm kind of I'm sure I'm teaching grandma to suck eggs there with all you experienced nav mesh developers, but bear with me for a second. Here an important setting, voxel size. So how granular is this whole geometry calculation which comes up with these surfaces. Okay, one important thing, okay, it doesn't matter for using the nav meshes in editor like we're doing now, but when we move to procedurally generated levels, it will be important actually what selection you what do you use as your basis of your nav mesh. So are you taking the render geometry, or are you taking colliders? In a lot of the cases it makes sense to use colliders because they're usually simplified compared to your beautiful looking level geometry. But in some case maybe you don't want to use colliders, you want to use the actual real deal. In this case you might need to take care of an extra thing, which is the import setting of the particular mesh. So okay, right now I'm highlighting here the slope. So let's do a quick check in Inspector. Yeah, this is my slope model. And the important setting here is read-write enabled in the import settings. So I'm mentioning it because I've already set it up, just in case I forget in the heat of the lecture. But if you are planning to do a procedural level, then make sure that all the models, if you decide to use their rendering meshes as the basis of the nav mesh, make sure you have read-write enabled. Well, let's test this quick nav mesh really quickly. So let's make a little agent object. So let's not make it too elaborate, just a new object. Maybe let's make it a capsule. This will also give us, okay, let's put it somewhere. Let's reset the position first. Bring it up. Okay, so it has a capsule collider, which is a very nice collider to use because it's inexpensive performance-wise. Let's give it a material. I already created the material there called agent, so it's red. And maybe let's scale this down to half on all axes. Cool, and again, bring it up. 0, 2. Is this fair? Yeah, this is workable. So what do we need for the agents to become intelligent? Artificial intelligence NavMesh agent component. So NavMesh agent, let me add that quickly. So the agent type is humanoid there. You can have different agent types which will be run by different NavMeshes, but in this case with defaults will be okay. And let's create a simple script to actually make this, make something happen. So let's create a script called pursue target. And at the moment this will be just very simple. We'll reuse it later for our procedurally generated crowd scene. Visual Studio loading. Okay, so pursue target. What will we need in this script? Well, we are using NavMeshes. We are using the AI namespace. So multi-engine AI. Okay, and we'll need a variable to hold the reference to the NavMesh agent. So I can make it private. Okay, yeah, we can populate this in the start method. So let's say nav agent. Maybe awake would be actually better, just to be sure. Well, it's fine for now. Okay, everything as usual. So in start method in the very beginning, we'll get the reference for the NavMesh agent component from this object. And in update, well, actually, let's do this at start since our NavMesh is going to be built already. So here we can set up a destination. So first let's provide a destination via inspector. So let's make a public transform destination, and destination is a vector 3, so it will have to be the position of this transform in world space. Okay, this is a very simple script, and let's see what's happening. Okay, let's rename this agent to agent. And let's add our new pursue behavior. And now for destination, let's put something up here in this area that we've just created. So let's make a goal. So maybe a small sphere. Just quick and dirty test if the whole thing just works as it should. Okay, I don't like this. 2, 5, and 0. Okay. Alright, it's a sphere that has a sphere collider as well. Let's make it smaller. And let's point the agent to the sphere as its goal. We maybe move this component up a little bit. Yes. So it's easier to work with. Okay. The nav mesh appears when you have the navigation tab active, so I can just quickly check everything is okay here. Alright, let's just run it. Okay, so the agent immediately does what it's expected, so uses the nav mesh to find the shortest path to the goal, and it all works fine. Can we change this a little bit? Let's say that the destination is going to be changing at runtime. Maybe we're chasing the player. So let's put this into the update function instead. I'm just changing the destination every frame. And let's try that. Okay, so agent is moving, it's following, okay, and there it fell off, actually walked off, finding the shortest path. So actually acting quite intelligently there. So that's a start. So that's already something that you can use to create a game-like experience for your final. But we'll make it more interesting. So okay, let me delete this sphere. What I've created here for this scene is a new version of the Nav City Manager. It's similar to the City Manager you were using before, but as you can see, there's no towers spawned, and there's a couple of prefabs set up as fields, public fields. So navigation tile, navigation slope up and slope down. If we have a look at this script, it's not very different from any of the other versions that we made so far. It's just to make it compatible in order not to have to break compatibility with the previous versions. It's just a little bit of a modification. What's changed? The city area is larger now, so I've had also some questions from people about the working with larger cities. So to do that, you have to remember there's a couple of places where the city array mapping is important. So in the beginning, we declare the city array to be a certain size. So in this case, we have a 40 by 40 by 40 slots. So kind of a cube with a side of 40 units. And then in the procedurally built blocks, in this case, this code is called, the script is called nav tower block. So this is the equivalent of our tree tower block. This is also using recursion. It's not super complex. It's not much more complicated than what you see with the tower, with the tree tower castle. But again, here the mapping between the world space position and the array indices, we had to change from what you had, those 7 in the tree tower example. Now we have 20 because we've shifted the whole city center. So now 20 is the array index corresponding to the middle position, because we have we are symmetrical around the origin and size 40, so that's where this 20 comes from. Maybe just for a quick comparison, let's actually let me just do this comparison here. So let's compare 2 files. So I'm just going to quickly find where this file sits. So we have tree tower block, and here we have nav tower block, and let's just compare by content. So here in red you can see the highlights of differences between the files. A lot of it stayed exactly the same. Some changes here. We don't have tree prefab anymore. We have instance of the navigation city manager. Okay, and then there's tree tower block is a bit more complex with all those different directions we were building blocks. In this case, it's actually looking a little bit simpler. Let me see. Bear with me just a moment. Okay, I might have lied. There, it's not nav tower block, it's root tile. Okay, what I'm talking about here is, okay, there's a nav tile. Let me drop this into the scene. Let me start somewhere at a certain distance from the ground. This nav tile will procedurally build the roads for us. So this is the code I've been talking about. So let me hit run, and you can see that something appears there. Again, it's random, so there's going to be cases where it ends up kind of short and not very impressive, and in some cases it will be larger and more complicated. So unfortunately I cannot build the nav mesh for this now in editor because I'm already in play mode, so that's definitely a limitation. Any questions so far? So let me go back to this comparison, the root tile versus the tree tower block, because these two I basically started with the tree tower block and modified it until I got the result I wanted. It's fairly similar. So again, let me compare the files by content, and you can kind of see that not that much is changed there. There's extra function there. Let's see. Okay, sorry. Okay, this is the real comparison I was going for. So quite a lot of different fields there, so I need to have prefabs for different types of tiles. What am I talking about? Well, let me give you a quick overview. What I'd like to do is start with this nav tile. Then in the very beginning I'd like to create like a crossroads, so I'd like to just expand by one, but just for the first one. And then as I continue I can maybe put a staircase going up, or a staircase going down, or maybe just extend with another flat segment. So in the end it's a similar mechanism that we used for the lab test example. So this is what this code is for. Feel free to have a look at it. There's a little bit of factorization that I did because now with these tiles it's important which direction they're facing, and so far we didn't really care about our building block orientation. Now since we have the slope, we need to turn around depending on the direction that we came from. So this is what these variables here are referring to: my slope, my rotation, and I won't be going into like details. It's it's probably a little bit beside the point, like I won't be testing you on that or anything, but here for example I needed to do a little change. Let's have a look at remember when you were calling the set slot location and you had to update the position based on where you want to be in the array. Now in this case it's a little bit more complicated because for example here I'm doing the crossroads, the initial split off in all four directions. So here's my little loop that goes from 0 to 360 every 90 degrees. Well, it doesn't do 360, it just does 0, 90, 180 and 270. And I've put this code, I've encapsulated into a set increments function. So this is actually going to define our increments in x and z, and also y based on slope. Y is the vertical, slope tells me whether the block I'm placing now is going to change the overall level to be placing the next tile after it. So this means that if I put a staircase in, then I'll be expecting the next tile block to be higher up. Anyway, this is just to kind of like give you a rough overview. I won't be going into detail about all of this, but here this set increments is an example of a factorization of trying not to repeat yourself, because if I had this whole bunch of code everywhere here that I want to place the new, so I'd have to have this section of code here, I'd have to have it here, I'd have to have it here, and I'd have to have it here. So you can imagine this would be a pretty nasty looking code that's just confusing. So use functions wherever possible and parameters. So how can we actually create a nav mesh for this procedurally generated road? Well, turns out we cannot really do it with the default Unity setup. For some reason Unity assigned this runtime functionality to something they maintain in a separate GitHub repository. This is called nav mesh components. So this would be used for the use cases would be like in our example when we generate our level on the fly, or maybe the connections, the situation that our game level changes after some event. For example, a tree falls over the road, so maybe the nav mesh needs to be updated, or maybe there's a new path after we complete a quest, and we add a section of another walkable area that will allow us a shortcut. So this is all not really possible if you need to bake the NavMesh in editor before play mode. So NavMesh components is what you're looking for. Here's the link. Have you used it? Anybody here of NavMesh components? It's completely new. If you hit this link here from the presentation, you'll get directly to the GitHub repo for it, and then you can clone and download it, and this will have you can add that to your project. Okay, well, regardless, I've added it to the project, so actually this is kind of this is here all that you need here in this subdirectory. So if you're making your project from scratch, you can maybe package out this folder or just copy it as it is. All it needs to have is a couple of scripts here and the editor folder, which has some GUI utility things which will help you working with it. So so let's try to use it. I've placed the nav tile in the scene. We have an agent. We're not going to use the agent yet, but maybe for now let's get rid of this agent. Let's make it into a prefab. Okay, and now I can delete it from here. So let's start with a straightforward example. Let's go to our Navigation City Manager, which is where things are happening right now. It's not doing anything in start or update. Let's just add some user-controlled functionality to bake the mesh after the fact. So I'm going to go to update function and just go, as usual, if input get key down, key code, let's say space to make it easy. We need a NavMesh surface reference to use our Navigation City Manager. So how does this work? Let's just create an empty object. Actually, this already is here, so let's stick with it. This is just an object which has this NavMesh surface component. This component comes from the NavMesh components package that I was just talking about, and here it has all its settings. So these settings, not all of them are selectable from this screen. Sometimes you need to go into the agent settings, and here you can, for example, reduce the slope, change the radius of the humanoid, or its height or step height. These values are okay. So you need to have this NavMesh surface, and it might make sense. Okay, one thing though, because we've just done it the other way, the Unity way. So navigation, okay, I'm sorry, I got a little confused there. So I'll clear this NavMesh, and let's forget this navigation tab existed, and now I'm just using the inspector on the NavMesh surface. So this is the actual one which we'll be using real time. Again, similarly as I was talking about, you can go into define your agent types, and you can also bake it now, just to kind of like make sure you populate it, but I don't think it's actually necessary. See what it did here? It took this whole flat surface and this one single tile and it baked it. The advanced options here, let's see. Objects, agents, I'm just looking at areas, okay. Oh, it took me to the navigation tab. Sorry. sorry for that. The NavMesh surface component. So there's a couple of components that are important. NavMesh surface is the main one, and that's all you need really today. And there's additional ones like NavMesh link. So for example, you might have separate NavMeshes which you'd like to connect via teleports, or maybe they are adjacent and you want to go from one to another. Sorry, Ian, you have a question or? No, I saw someone typing. Oh, by the way, is there problems with the video quality? Like, should I? Are you having a jittery? I'm sorry, I should have asked. I mean, I could try reducing the bandwidth if some people are having problems. This Nitro should be improving things a little bit, but okay. Okay, the code. Okay, good point. Okay, so I'll keep the bandwidth and I'll just try to zoom in a little bit. Okay. Yeah, the recording should be full HD quality, so if you need to revisit that, yeah. Okay, you should have spoken up. Like I'm assuming that you know, if you're not saying anything, that everything is okay. Well, don't be shy. Okay. And I'm not always listening to, and I'm not always reading the comments as I speak. Just you know, trying to maintain focus. Okay, so as you see, we've just baked it again in the editor, but we'd like to do this now real time. So we have our NavMesh surface object, and we'll need a reference to it. So Nav City Manager. So the Navigation City Manager now has a reference to the NavMesh surface. Okay, let me see, control. Give me just a moment. No, we're not that strict there. So I'm trying to remember is it Windows Plus? Yeah, that's the one. I'm just a little bit afraid what it's gonna do to the stream because I mean, it's a kind of a complex setup. So let's see if I do it on this window now. It's doing it for both screens. I'm not sure if I'm still recording what I should be recording. How is it looking now? Okay. Well, it might depend on if your connection doesn't manage the full resolution. Well, I could see. Yeah, well, I agree. It's a bit of a problem. Well, let's take a 10-minute break, and I'll be back with you. I'll see what I can fix on my end.